Okay, hello everyone, and welcome to this class. I believe you can hear me, isn't it? Please confirm on the at the chat, please. Okay, thank you very much. As you must be aware, today we are running practical session, okay? And the practical session is based on dynamic processes in electrical power systems. And today we are using DIgSILENT PowerFactory. As you must be aware, I already upload many videos at YouTube, and you have the links. And you can go over there and see few details about the test system that I will use today, okay? Today I am using the same test system that it was used in, I think, 3 or 4 videos before, okay? I remember that the first video was related to creating a test system, and that is the videos, the file 0 over here in my GitHub. The file 0 test system is basically the file that I used to show in the video, creating a single generator connected to an infinity bus bar. Okay. The second file here is the number 1 test file again, and that is the file that I use for creating the pre-contingency analysis. Okay, you also have a couple of videos regarding this. Okay, finally, the last file here, the number 2 that you can see, it's basically the file that I use, the DIgSILENT PowerFactory file that I use when I create the video regarding the initial conditions. Okay. Today the class will be running a time domain simulation using the DIgSILENT PowerFactory, and the job will be extremely simple. Okay, I don't want to use so much of your time because you feel that you are overloaded, but I will just explain how to use the basic functionalities that I already explained in YouTube, but let me do it here in live in order that my student can hear my voice in real time. Okay. I believe all of you already download this file. Please download this file. And what I will do now is I will open PowerFactory, and I will open this file, the test system, the second test system here. Okay, I will do that in my version of PowerFactory. Okay, let me close this, and I will go to PowerFactory. Okay, here you can see this is the screen. I think let me see if it's shared with my students. Yes, my student, they can see my PowerFactory screen over there. Okay, what I will do is I will import the file that I already download from my GitHub. Okay, I will import into PowerFactory. It's extremely simple. If you are familiar with PowerFactory and there are many functionalities, you can just take the file and drop it here, and PowerFactory will ask you what is the location that you want to use, and I will put here inside a folder, and now I have here the file. Okay, now I have here the test system, and this is the test system number 2, and I will change the name. Okay, to change the name is extremely simple. What I will do is right button. Okay, with the right button you have the possibility of using the context menu. Okay, and over there is a functionality like classic Windows, rename. Okay, and I will change the name, and right now the name will be 3.0 3 point, and then I will change at the very end, and I will call this time domain. Okay, time domain. finally. Okay, let me summarize what I have done. I download from my GitHub repository. I download the file, and then I import it into DIgSILENT PowerFactory. Okay. After I imported into PowerFactory, what I did is I rename it. Okay, I rename it, and right now the name is 3 test system SMIB time domain. Okay, that is what I have done until now. Next step, well, I will start to do some practical stuff here, and I need to activate the file. Okay, what I will do is remember, this is a project. We are inside the data manager. What I will do is simple right button, activate. And right now in front of you, let me close the data manager. I close the data manager. And in front of you, you have this extremely basic, extremely simple system, okay? And this system is basically a synchronous generator connected to a bus bar. From the bus bar, we have a step-up transformer going from 11 kV to 232 kV. Then there are two transmission lines. And then we are going to the infinity bus bar, okay? However, all the explanation regarding this is already in YouTube. You can go over there, watch the videos, and also you can see how I create this, okay? Extremely simple. First step. The first step is I would like to be sure that we have the proper model, okay? And to do that, what I will do is just running a load flow, okay? What I will do is run a load flow, sorry. You can go here to the, the icon here for bus bar, or you can go to calculations, load flow, and then select load flow, okay? I will do this approach. I will use this approach because this is the one that is extremely simple for my student to see, okay? Again, to run a load flow, go to calculations, calculation load flow here, and now we have the window for the calculation functionality, the calculation method for the load flow, okay? We will not change anything here, okay? We will not change anything here because we are using the default settings. That means we are using a calculation method based on AC load flow. This is a balanced positive sequence load flow. I will run the load flow, execute, done, okay? And right now what I want to check is if this load flow is properly working. And I can see here that we fulfill the requirement at the statement, because if you remember in the first video of the series, I say that the power supply to the infinity bus bar is 60 megawatts. And you must remember this issue with the power factor, and the power factor over there is 0.8, okay? Conclusion here, the conclusion is that we run the classical load flow and we got the results that we were expecting, because these confirm those numerical results. They confirm that we are using the data that it was given in the original statement, okay? That is extremely good news, okay? Next step. Okay, the next step is let's do the following, okay? Let's do the following. Next step, I will go here. You have a menu, and as you can see, the simulation RMS and AMT must be selected, okay? I will repeat again. There is a small triangle here with black color, and that is the menu that allows you to select different toolboxes. and I will select here simulation, RMS, and AMT, okay? Extremely simple. When you select that, you have a set of icons here at the top. You can see here there are several icons, and the first one you can see, you can stop over the cursor over there, the pointer, and you can see that the first icon from the left to the right is calculating initial conditions, and the one that is near to the right hand, that is start simulation, okay? At this moment, what I want to do is just run initial conditions, okay? I will run the initial conditions, and PowerFactory do the magic for me, okay? Because as you can see here in the output window, PowerFactory is telling me, okay, all the controllers are properly working, we have a reference bus bar, and the initial conditions are done, okay? Initial conditions are calculated, we are right, we are ready to do the simulation, okay? Okay, as you can see over here, if you remember my previous video about initial conditions, you can check the initial conditions, but those numbers are fine, okay? Because if you remember my video about initial conditions, the internal voltage of the synchronous machine, we are using the most basic model for the synchronous machine. In this case, the internal voltage is 1.247 per unit, and that is totally right, okay? Also, if you remember, when we run the initial conditions, we can obtain also the internal angle of the machine, okay? And in that case, we can check again with the previous video, and the angle is 13.214, okay? Well, coming back to my explanation, we have done nothing relevant at the moment. We just check the sanity of this model, okay? It's very important that you check the hygiene or the sanity of your model before start to do anything else, okay? Right now we are sure. We check the load flow. The load flow is fine. We have here the power factor 0.8. Then we check here the initial conditions, and we can see, we check here the initial conditions, and you can see here the internal voltage and the internal angle. That means that this model is properly working, okay? Okay, right now what I will do is I will explain how to run a simulation, a time domain simulation using PowerFactory, okay? One thing that you must remember is that this button over here, initial condition, must be used a lot, okay? Because when you are configuring, when you are setting up your time domain simulation, you always must have the initial conditions loaded in your model, okay? Okay, let's start our time domain simulation. What I will do first is, let me clear the output window, and I go down here and I clear the output window, okay? I will do it again. I move my cursor here to the output window. You can see over here my cursor here on the top of the output window. Select clear, confirm. Now the output window is clear. Next step, I will run initial conditions. To do that, I will go to the toolbar here at the top, and I will select here the icon for initial conditions, okay? And as you must be aware, in this course, we are running RMS simulations. In this course, we are not running any AMT simulation, okay? In this course, we are not running any AMT simulation, okay? We are running just RMS simulation. And regarding network representation, In this class and also in this module, we are using only balanced positive sequence representation. Okay? And I will select here, execute, and we have over there the initial conditions. What is the next step? The next step is I would like to assess the dynamic performance of this power system, but I would like to assess the performance basically using a large disturbance. And a large disturbance is basically a short circuit, okay? Now what we need to do is define an event. Inside PowerFactory, the short circuit is called event. Event is the object that is used inside PowerFactory to simulate any kind of disturbance, okay? Now, let me tell you, there are two ways to create an event inside PowerFactory, okay? There are two different ways to do it. However, my students, they say that I am overloading there. Let me teach you the basic way to do this, okay? Because they say that there are so much work in this course, and let me do it in a very basic way, okay? The first step is select with a click. You just put your cursor, put your pointer above the bus bar name HV and a click, okay? And then press right button. When you press right button, you will have the possibility of defining the event that you want to define, okay? I will do it again in slow motion. First step, click at the bus bar HV, then right button, then right button, and then from the right button, we will say define, okay? When you see over there, there is something that say define, and you have several options in this menu over here, okay? There are several options in this menu over here. And again, coming back to my explanation, you have here, okay, define, then I will go for define a short circuit. There are different things that you can do with this context menu. There are many things that you can do with that. However, the issue is we will select here the first option. And the first option is clearly to define a short circuit event, okay? Okay, what I will do now is click here, and at this moment, PowerFactory is creating for me an event. And this is a short circuit event, okay? If you look here at the top of this, if you look over there at the top, you can see that over there you can read the object name. And this is a short circuit event, and you can see the short name EvtXXX. This is a short circuit event, okay? Here, when we are configuring the short circuit event, there are several things that we need to consider, okay? First is the time where the short circuit is inserted into the power system. In this case, we can define hours, minutes, and seconds, okay? For this very specific exercise, I will assume that the short circuit is installed, the short circuit is inserted when you are at t equals 0. Again, I will repeat again. Regarding execution time, that is the first section of this configuration, I will define 0 as the moment, the instant where the short circuit happened. Okay. Then you can see here below. There is an object where the short circuit is applied. And for you, PowerFactory help you. And the object, you can see over here the name. This is the HV. This is the HV bus bar. Okay. Then below, we can define the different type of short circuit. Okay. You can see over there, PowerFactory have an amazing selection of short circuit that you can define. You can define 3-phase short circuit, 2-phase short circuit, single-phase short circuit, blah, 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 blah. Okay. However, remember the following. We are running a positive sequence simulation. And because we are running a positive sequence simulation, in this case, the only case is 3-phase short circuits. Because 3-phase short circuits, they are symmetrical faults. You must remember that from your previous course. And 3-phase faults, they are symmetrical and balanced. Okay. That means we are right. Let's select here, keep the selection, 3-phase. PowerFactory also has a very interesting and very important feature, okay? In real life, when we are working in real power systems, there is a possibility that the fault, the short circuit fault, has an impedance. That impedance can be represented using resistance and reactance, okay? In that case, if we have resistance and reactance, we can include here the values, okay? Later at home, I highly suggest that you change those values and you will be able to understand the implications of having different resistant values, okay? At this moment, I will leave alone this value. I will say 0 here at the resistance fault and here 0 at the reactance, okay? And to be honest, right now there is nothing else to modify here. Just press OK. And voila. Welcome to PowerFactory time domain simulation. You have already defined the disturbance. In this case, inside PowerFactory, we call that basically the event, okay?